Yeah. Got to translate this one to struct multiply. Looks a lot like addition. I would say exactly like addition. Better commit everything that I have so far first. So the example is add.h, and then I move code from product.h to multiply.h. This thing starts with a for declaration of add equals. And here we have a multiply unequals and a make power. So this thing has two of them. No, let's use this as the for declaration of make power. And I also need to make power t then. Which then I suppose I can remove it, that one here. Anonymous namespace. Wait a minute. Let's remove that. That makes things a little bit too complex at the moment. Okay, and then I need multiply unequals for declaration. Also in namespace anonymous. Let's also remove that one. Next. And add.h begins with canonical constant and condition type traits. Definitely going to need those as well. And that then already for declares symbol and product. think this should should still compile, even though I moved some stuff. Let's try that is the case. Okay, what the hell? Undo? No. Redo? Redo? Right. Write everything. Okay. Removed anonymous namespaces. Moved the abbreviation underscore T thingy to this header. For declaration of make power and multiply on equals. On college, was it missing semicolon? Nah. What is this? Expected unqualified ID. Oh, yeah, never mind. Well, actually, it is a missing semicolon. Okay, so indeed, that was not a change, basically. It just worked as before. Then we go back to add.h as the example. Hello, Abhishek. Add. Okay, so now I'm having an add which is just the struct, but this one is for the case where neither is a sum. Maybe I should add a comment. This default is for when E1 or E2 is a sum. Initializations below. So the default is for neither is a sum. And in the case of the product, that corresponds with this top thing where neither is a product. But let's begin with defining it. So that is for a multiply, that is going to replace this thing. Paste it here. So this is multiply. This is what we don't want. Okay. Default is when neither is a product. And then I need to do this, but I'm too lazy to do the translation. So I'm first pasting it, and then I look at add again. This is using, well, copy everything. First you copy everything, and then we have everything on one screen, and then we can fix it. Right. Okay. So now we make a type and we have to use conditional type, and then we get is less product. It's just this one. Copy that one. If is less product, E1, E2, immediately return. So I don't even have an if else here. So we return a type which looks like just this, I think. Delay template then. And the template is multiply on equals. Else if delayed conditional type is less product. E2, E1, that is that one. And then again, just the type. So this can all be removed. The same thing, but then E2 and E1 swapped. Else delay template make power. E1, E2. Yeah, well, it looks like the same thing. I think the natural indentation is just 2 spaces. Yeah. So that's for the default, where neither is a product. Sorry, Abhishek asked how much experience you have in this sector. From what you can, I have 30 plus years. I'll type it in. 30 plus years C++ experience. And I started coding when I was 12, which was very long ago. So that's, I'm now 59. 47 years, yeah, 47 years of coding. Hilario, thanks, man. But of course, all of this syntax didn't exist a few years ago, so it's kind of new to me too. But yeah, I'm starting to get a hang of it after having done this for a week or two. Let's put it this way, you know, if you look at this and you say, oh my God, this guy is so good, 30 plus years, I will never know this. Well, I didn't know this 2 weeks ago. I had absolutely no clue that I had to do it like that. It's just a matter of not telling yourself that you can't do it, but just do it. And if there's a little thing that you can't do, then you look it up. And then you keep using it until you become expert in it. The only thing I did not write was, and sometimes I need help, I just can't figure it out. So this was, I got help to write this. This part I did not write, and I could not figure it out either. It's the delayed stuff, delayed template and delayed conditional type. if you look at it, it's not even that difficult. But yeah, I don't know. I couldn't figure it out. So next, go back to my example again. Add. So we start with the default struct. And then, yeah, the abbreviation for that. That would be multiply underscore t. Well, I should already have that. Yeah. And then below that we get the specialization for a constant. So that works as follows. Well, we have struct add, which is a template. And then you want a specialization for a struct or a class. Then you just repeat the declaration or definition again, like here. But now with angle brackets. And then you just fill in the types that you wanted to specialize it for. So here we have two expressions, which this is a concept, right? So this is C++20, I think, concepts. So normally it's like a type name, you know, type name, but you can also use a concept which is has a certain restriction. In this case, an expression means that E1 must be derived from the base class expression tag, which is just an empty class. I might have well dropped that because that was mostly because I was using it for operators. So if I define operator plus for arbitrary type names, then it would even start to call that for two integers. And of course I did only want to define things for my special classes. But now it is a symbolic, it's the namespace, add. Yeah, it still will only work for all the classes that they derived from expression tag, but it won't accidentally start using symbolic add unless I really intend to. So it's not that important anymore to use in a concept here. Anyway, so you have two types, E1 and E2 are pretty arbitrary types. And then they say, now I want E1 to be a more specialized type, namely a constant, which still can have template parameters. Whatever template parameters are known, you just add here. And the second one must also be a constant and also has two template parameters that we don't need to specify. As being template parameter. And then if you want to use the struct add with two types, and those types match the constants both, then it will use this definition. And otherwise fall back to that one. That's how the specialization works. No, I already had const, and now we get a specialization for sum. So this was for constant something, and I have a specialization for one of them being a sum. We have to repeat that now for, well, the second one is a sum here, and here the first one is a sum, is a specialization, and both being a sum is a specialization. Nothing after that, so you don't even have to look at this file anymore. So one being a product, if we keep the order the same, then in this case, if we get here, then it is not the case that neither is a product. So if E1 is not a product, then E2 must be a product. So it's kind of strange now that we start with the code where E2 is a product. Otherwise you would think like, yeah, well, then begin with E1, but no. It doesn't matter anyway, I guess. But I'll keep the order the same. So this belongs to E2 being a product. I'm going to add that specialization below the constant here. Yep, so now we're going to do the same thing. I'm going to redefine this struct here. But I'm going to specify the types. And the first type I don't care, and the second type now must be a product. Now, product takes also template parameters. Arbitrary, I guess. Just arbitrary expressions. I'll call it E2 and E3. So we have now 3 expressions. Let me, before I do the replace this code with the using type, I'm going to do the other 2 as well. The remaining 2 specializations. So I'm also having a specialization where the first one is a product. And the second one is not. And then finally we have one where both are products. And also get the code for that. Why the hell do I end up here? Oh, I jumped to it? No, I don't know. So this is for when E1 is a product. And this is for when both are products. Copy. E1 is a product. I think I missed something because it starts with an else. Well, I'll have to go back anyway then. Oh, wait a minute. It's like that. Yeah, okay. So it was correct, of course. I just forgot it as a whole block. Never mind. So this one contains that one code. Now let's translate it. See if we can do that from my head without looking again at, well, head. I mean, I'm just looking at this now. Type is if conditional type the condition, comma, indentation, delay template, the templates, the template parameters, comma, else if delayed conditional type, and then the second condition. I'm making the same mistake as before. Okay, I'll fix it afterwards. Delayed conditional type, and then the next condition, and then we get delayed templates, the next one, this is this one, comma, the template arguments. Close one, delete conditional type and the conditional type. But yeah, the E1, we had an E1 and E2, but now E2 is actually product. So everywhere where we see E1, we need to use E1, but everywhere we have E2, we need to use the new types. And then E2 arg1 is actually E2, and E2 arg2, this one is then E3. So there's not going to be an E2 colon anymore. So this is let's just do it like that. So I do a substitute E2 double colon. Oops, start with type name. Type name E2 colon arg1 is now E2. And E3 is the same thing, but then arg2. And then I edited the wrong code block. But hey, I can repeat it. That one and that one. Okay. Yay, Vim. Hi, Carl. Hey, yeah. You're a programmer too, professional. Let me think. Conditional type. I think that's correct, but I have to check it anyway. So if E1 is less than E2, then we do it like that. Otherwise, if E2 is less than E1, then we put E2 first. Something's wrong here. This E2 is not correct. That should be the product. Okay, now I'm confused. Damn it. Now I don't know anymore which was my substitution and which wasn't. I'm gonna go all the way back. So I replaced this with E2, but we also have an E2 here without double colon. Should change that one first. Hey, I spotted it. I spotted it. So E2 is actually the product. E2 has become a product. Yeah, so if you fill that in, the product here, and then you just get the first argument of the product. And now that becomes E2. That's how it works. That was the only standalone E2, I think. As long as we get everything in the product in the end. So if E1 is less than E2, This is the actual E2, the first one of the product. A product always has things ordered, so E2 is less than E3 per definition. Otherwise the product would not be ordered. Whatever less it means in this case. Don't worry about that. So if E1 is even less than E2, then I do E1 first, or the smallest one first, followed by the product. And if E2 is less than E1, then E2 becomes before E1, but I don't know if E1 comes before E3 or the other way around. So I just call recursively multiply again. And then it sorts, it either keeps it like that or it swaps E1 and E3. Or maybe E3 is again a product, so it's just, I don't know, this sort of stuff. It's a compile time type-based sorting. That's insane. And then we have the case where both are false, so E1 is not less than E2, and E2 is not less than E1, which means they are equal. And then I make a power of it. For example, E1 and E2 are the same symbol, and you just get the square of it. But it's also equal when one is a symbol and the other is a power, or they are both powers with different exponents. So make power just adds exponents in. And then fixes the type again in the case that the exponent becomes -1 or 1 or something like that. Hello, pi. I'm going to call you pi. No, I don't. Yeah, it looks good, right? I mean, it has to look good. It's just good. Just delete this. Using type equals if I get confused. I thought I was working on this one. Oh, I just did this one. Did the default, and this is the first specialization, I guess. No, okay. Yeah, okay, yeah. Conditional type. So I do it at once now, because now you know E1 arg1 type. So I'm going to copy this, but then fill in the right types immediately. So E1 arg1 is E1, comma, and then E2 is now E3. Comma, and then delete template. That's the template. And then the types, E1 arg1 is E1. And then I get multiply. I have to delete it as well, I think. Or not, because I got rid of this. Why would I even delay it? It's annoying. It does it again. The problem here is that if the conditional type is false, then we would normally not use this. But the compiler is going to follow, evaluate whatever the whole type anyway, unless it's delayed. So would you just fill in? I'm going to just fill it in, but might not work. If you just fill in this type, then it's going to try to figure out what the type is, even if the condition is wrong. which is sometimes not possible. But this is only about less, so I guess just a waste of CPU, but nothing else. Although you might for really complex types, you might get into a loop. I don't think that my test suite even has that kind of difficult types. Because it just feels wrong to try to figure out a product where this less is wrong. Because this is sorting, right? So if I say if I tell the compiler to try to multiply, oh wait a minute, it's a multiply underscore t. But still, I mean, this is a recursive call. And if you follow the right branches where everything is true, and you only follow the true branches, then it results in a sorted product. But if you also follow false branches, then I have the feeling that we might end up with not sorting in a certain branch, following false branches. And that might then end up to be infinite long. I'm going to delay it. So this must also be delay template. That is this one. So then we get E1 arc2, which is now E2, comma E2, which is now E3. Delay templates. Wait a minute, this should be a comma. And then the other delay templates, and then probably a comma. Else if. And then delayed conditional type. This, where E2 is now E3. And E1 arg1 is E1. Delay template, multiply on equals, comma, E2, which is now E3, E1, which is now the product of E1 and E2. Close the delayed templates, comma, else. The last one, delay templates, multiply, and the make power. You probably should delay that as well then. So again, a delay template, power of E2, which is E3, comma, E1 arg1, which is E1, comma, E1 arg2, which is E2. Close the delay template. What are we multiplying here? The power with this. See how I had to close it there as well. So this then closing the second delay template. And then we are at the end. So now I can close the delayed two delays to conditionals. I don't know what happened. Undo. Insert. Demic1. I think that should do it. And then the waste of your life, you have to check it. Well, if E1 is less than E3, then we get just E1 followed by multiplication of E2 and E3, that looks good. Yeah. Yeah, must be good. Yeah, one more. Using type is if conditional type now all of them have double columns, so I think I'm going to do a search and replace here. That must be faster. So I'm just going to copy the exact condition the way it is now, and then you get the delay template for this template, comma, that type, comma, oh fuck. No. Again, a delay template, multiply 1, 2, close off, delete, and then close the other delays. Else if what would be this on? Delete conditional type. One, and then again that shit. Another delay type. Maybe we should make a delay to multiply, because this looks like a miss. This even has 3 of them. Baha. Delay templates. Again a multiply. Come on. Delay template. The power. 2 types and a close, comma. Oh, I can just copy everything. So I had 1, 2, 3 opening things, and then 1, 2, 3 closing things. And now we need 2 closing things for the delayed conditionals. That one and that one. Well, that's it. And then we need to do the following. Substitute E1. Well, wait. Type name, and just copy it like that. Whoop. That whole thing is E1. And then E2 is arg2. And E3 is arg1 of E2. And E4 is arg2 of that. Now, let's check it again. To a conditional type less than arg1. E2 delayed on conditional E1. Arg1 delayed template multiply. Yeah, that's not good, of course. There was still an E2. So there was no double colons, so there was one left. And here's another one. Yep. Okay, so what did it say? The product, I just filled it in. I don't know the number of braces, angle brackets here, but one for the product, one for delayed, and one for the other delayed template. Else delayed is less product. Yeah. And then we got yeah, so this E1 here is not correct. That should be this. Okay. Delete. That was the last thing in terms of copying. Let's just see if this compiles. Does not compile. Instantiation of struct delayed template multiply unequals t. Symbol 10 delayed template. Required. Template constraint failure. Yeah, I don't think I even have got the faintest idea. Just one faint idea actually, but the arrow isn't very clear, is it? It just says in instantiation, and then the requires is usually not super interesting, but there's a lot of requires. Template constraint failure. I mean, dude, what? Okay, so here I have a multiply of a product of two symbols with another symbol. That is really weird because the test suit said it is a multiplication of 4 symbols. Before that, we already tried every combination of multiplying 3 symbols. So how can it fail on something with 3 symbols? Here I have 4 symbols. Operator star with E1 is the product between symbol 9 and the product of symbol 10 and 11, all multiplied with symbol 12. That's 4. And then one line higher, I have just symbol 10, 11 and 12 left. Where did symbol 9 go to? It's still using the old code, by the way. I was just testing if my new header had problems with compiling, and then the test suit fails on the old code. Yeah, this is the untranslated code. But it is using multiply type. That has to be mentioned. So it's already using it. Okay, it's going to call, well, I call it call, but whatever. Multiply unequals with symbol 9 is the first argument, and now it barfs on this one. Where that which is then now not strange, because when the test suit did 3 symbols, it used this code, which is the old code, and the new code is the multiply underscore t. So apparently the multiply underscore t does not work for 3 symbols, but I never tested that before. And not working for 3 symbols means that E1 arc2 type is then well, we can see that in the error again. So it is calling multiply t. To this operator. Using this multiply t, where E1 is a product between 10 and 11, and the next argument is symbol 12. That is not working. Should it work? Yes, of course it should work. It's already ordered, by the way. But product is not allowed to start with... I mean, this must become a product of 10 times 11 times 12, yeah, in that order. But product's first template argument is not allowed to be a product. So I can't make this a product of a product and a symbol. It has to end up as a product of a symbol with a product. So you must end with a product, first argument symbol 10, comma, product, symbol 11, comma, symbol 12. If you get what I mean. This is the first time we enter multiply.h. And we're talking about a multiply underscore t with first argument being a product and the second a symbol. Okay, so that should end us up lower. I'm gonna just look hard. It's 36, not the one. So that one. So that's correct. I mean, it uses the correct specialization where the first argument is a product and the second one is a symbol. We now know, but not a product. And the order, like I said, was already correct. So these two are also symbols. Symbol, what was it? 10, 11, and 12. So definitely symbol 10 is less than 12. So this is then true. So it should be doing this one. Returning multiply on equals t. Using E1 and the multiplication of E2 and E3. Let's go one higher, I don't know. That was 5.9. It goes to conditional type. Okay. Using conditional type is conditional type, of course, type. It's not super interesting, but you can already see what it is. Condition is true. True trait is delayed template. Multiply on equals. That's not the one that we were looking for, right? Symbol 10, delay template multiply. Oh wait, it is. Let's copy this. Delay with multiply of that. This is what it should be using because condition is true. That is this line. Yep. So in the correct line. In the correct line, 5, 9. Well, this is just an abbreviation, so that's not very interesting. And then the one above that is 3, 5, 3, 1. And that's the last one. Straight conditional type true delayed template. Multiply on equals t. Symbol 10 delay template multiplies. Okay. For the true one, yeah. So it's still the same thing. What? Type. Yeah. Well, but. So that's, and that was the end. Okay, so the true one, that is then this one, delay template, multiply on equals, symbol 10, again delay template, which you didn't even enter yet. That part. And that then tries to instantiate. It is called instantiation. Okay. Struct delayed template, that would be this one. Multiply on equals t, symbol 10, just what I highlighted. Delayed template. What is this? Multiply t. Yeah. Template constraint failure. Does the error not stop here? Does it continue? No, it's something else. Anyway, yeah, I think that this is where little light is shine on it. It fails on the fact that delayed template is not derived from expression tag, it seems. Yeah, I think I'm getting it. Finally, that took a long time. Okay, now I have to hold on to it, of course. Oh, my brain is hurting. The problem is related to having a nested delay template, where actually the delayed only works if it is direct template argument of a conditional type or a delayed conditional type. But now I'm using it as a template parameter of a delay template, which is not correct. Namely, delay template expects types, while the delay template itself returns a type that whose type is the type. So maybe it works if I use type name type, or I can just introduce a new thing called delay template underscore t. Let's begin looking at where we are now. Oh, that's considerably lower, I think. Yeah, so multiplication works now. Apparently, at least all of this works now. So before we were stuck on this one, and now we're no longer stuck on it. Now we're stuck on exponentiation or something. Invalid use of incomplete type. Get exponent. In power.h. What's this lowest line number of power.h? 60. Well, that's just a get exponent type. Declaration, struct, get exponent. Yeah, okay, get exponent is not defined there. I wonder what that has to do with moving stuff to multiply.h, but well. It's defined in line 69, after 69, and now we're trying to do something from 99, isn't it? It's required from, so. Why would that not work then? Or I'm trying to do trying to do an exponent that doesn't have an exponent. I think you can only do exponents on symbol and powers, and I'm trying to get it on an other type, I suppose. Expression. Yeah, on a constant. Constant is not a symbol, it does not have a power. I could return 0, but no, just never get here. So it's missing delayed somewhere. Get exponent required from here. That does call, yeah, get exponent. That's make power, but then the power should never have been called. So the question is, who is calling the make power on this type? Required from make power, required by substitution. Ah, fuck. Required from there. And that didn't help either. 36 required from here. That is a delay template. Okay, I'll look at it, even though I know that it doesn't help. And then that was number 19, line number 19. Yeah, 71. And then which line was it? Must be the last one, right? Because it is a calling make power. $71. Yeah. So we entered this thing. In other words, E1 is that power. E2 is that constant. Get another product. E3 is that symbol. And E4 is that symbol. No, it's not. Ugh. It is the multiplication of this product with this product. Okay. Is less than E1, E3. I'm not sure. I don't think that power is less than the other power. Does it look at... I don't know. Is it less product for two powers? It's only less if this exists, and it only exists when the ID of the symbol is less. Exponents are not being looked at. So it's not less because the symbol was the same. Both symbol 1. So this is false. And then we get is less product E3, E1. That's the other way around, but it's also not true. It's still the same symbol. So then we get this. Which then is evaluated. So multiply t is, let's call it instantiated, because I think the compiler mentioned it like that. Multiply t is instantiated. Well, maybe it is instantiated. I mean, it's an empty struct. It's just about the type. But I think that if you use a type in the way that we're using it now, within quotes, it would instantiate a constructor, for example, if that existed. So you could call it instantiation of the type. So that would be instantiating a multiply t with template parameters that and e4. And we never get there because I'm inside this multiply. I would say we never get there. But it went wrong in make power, didn't it? Line 71. So it goes to 36 now. No, it goes to this one. Quite transfer delayed template. Multiply t. Okay, this one worked. So make power of E1 and E3. E1 is that symbol 1 to the power minus 2. And E3 is symbol 1 to the power 2. So you multiply those, you get symbol 1 to the power 0, which is 1. So this thing is that thing. So I think that this multiply t, wait a minute, it's a constant and very confusing with the product. It's a product of that. Or that must be, what that E2, no. Oh, that is E2. Okay. Yeah. Okay, now I finally see it. I was confused by the fact that E4 is symbol 3, so I thought this symbol 3 is that E4, but it's not. This symbol 3 is that symbol 3. This is part of E2. It's this E2. So the E2 is that. And this delay template resulted in this constant. So I think it's not this delay template, it's this delay template. Yeah, this is the E4. No, this is the E2. Okay, we're dealing with this delay template. That one worked out to be constant 1. So now it should be multiplying 1 with this product, which should return just the product. And now I'm confused about what is going wrong then. Yeah, go one higher, I guess. So that is again calling conditional type, which is then calling that one. 36, also not super interesting. 37. Okay, now we're going to multiply this one. Is the result. Where E1 then should be the constant and the product, yeah? So we have these types again already, I mean, but let's make sure that this line number mentions them as well. 47, here's 47, yep, it's a multiply of the constant with the product. The same things that we saw below. We're already inside multiply, I can just do product. So E1 is this. E2 is that one. And E3 is that one. Which then should be doing the following. Less E1 as a constant and E2, that is true. Constant is always less than a symbol. Delayed, so we are going to get here. Multiply on equals E1 and the product. Yeah. Line 47. That then calls line 13 with E1. So it comes to template equals blah blah blah. Make power with. That doesn't make any sense. Or does it? I'm not sure. No, it does not make sense. You cannot make a power of a constant, I think. Anyway, look at it. We are calling make power with E1 is with those things. I think I need to be on the same. Yeah, I think I found it. The make power is type is not delayed here. We should be doing this line, but it processes every line regardless of the true value. And although the multiplier is delayed, the power is not delayed. So it's trying to calculate and make power, even though this one is true. This is so annoying. And here I have another thing. I mean, probably don't want to do anything in that when it is not true. So everything should be delayed. So here we just add another delay then with an underscore t. And here as well. Yeah, and then we do that for everything, right? So how do we find the everything? I think I always have at least one. It's probably something like comma space and then one of those. So let's begin with make power. That doesn't exist in this file anymore apparently. And the other one is multiply on equals. Also not. It gives us hope. Clip comma that thing. Nope. Must be an X. Whoa, doesn't exist. Very good. Make power. Also, that was the last one? Really? Well. Wrong number of template arguments. Those are easy. I thought it would be easy. I just changed this line. Oh, this is one. An angle bracket too much somewhere. There. Okay. So, did I do the same here? No, I didn't. This one is correct. Yep. No. Still calling. Still calling make power with the constant as first one. Why? Just like nothing changed. Yeah, what? Is it still doing this thing? No, impossible. Possible. No, not impossible. Oh, fuck. Okay. That doesn't help. I think it doesn't help to use this. The trick is that this returns a struct with a type, which is then only evaluated by that thing if the condition is true. But here I'm just calling an abbreviation that does the delayed template on something and then has the colon type directly after it. So that's not working. I have to make this a double delayed thing. So here I'm doing an else, which is just not working. You have to make it an else if. To really block. Well, no, this is not entirely true. Wait a minute, damn it. Yeah, I think I I think I have to make power type just work. I mean, not barf out if you call it with the wrong template, because that's what's happening here. And I don't think the delay template T is really working. Anyway, although I did something. Where am I using that now? Using it quite a lot already. I can't believe that it does anything, really. Starting to think to do something really dirty. So I want to have a const expression conditional type, where if this is true or false, it causes the other branch not to be instantiated at all. And I think the way that this can be done is by that would be too dirty, right? It's just too dirty. I could write a function that returns a type and then get the declaration type of that function. And then inside the function we can use if const expression. Or maybe we should just repeat the delayed condition. Every time I need a delayed underscore T. Then you get something really looking bad again. You said maybe you can improve again with other helper templates. Let's see if we can make that work. So the idea now is that this thing must be only instantiated. Is that not possible when you use an enable if type or something like that? Additional type? No. Actually, I could use delayed. Let me try this. So the idea is that this, you want this, but the underscore T is not working. I just have to wrap it into conditional type. And I can use the same thing here. I think this is processed already anyway. I'll do it like that for now. Okay, before I do that, let's do another commit, even though it doesn't work. that void type or not? No. Void type is just void. Can't really be happy with this, right? Ridiculous complex. Oh, it's another type here. Missing core or something. How can that not have worked? Yep, we have lift off. It seems to have worked. So now I can do the same thing here. Sorry. I think someone is ringing